Okay, for Module 5, networking and content delivery. So this is more near to us as a network student. So this module covers three fundamental Amazon Web Services, AWS, for networking and content delivery, Amazon Virtual Private Cloud, Amazon VPC, Amazon Route 53, so and Amazon CloudFront. So all about service that are offered by Amazon AWS. So let's go. So after completing this module, you should be able to recognize the basic of networking, describe virtual networking in the cloud with Amazon VPC, label a network diagram, design a VPC architecture. So indicate the step to build a VPC, identify security groups, create your own VPC and add additional components to it to produce a customized network. And then identify the fundamentals of Route 53. Route 53 is like DNS server. So recognize the benefits of Amazon CloudFront. So CloudFront ni macam macam apa macam cache center. Okay. So this basic networking. So in this section, we will review a few basic networking concepts that provide the necessary foundation to your understanding of the AWS networking service, Amazon Virtual Private Cloud, or we call Amazon VPC. So Amazon VPC ni dia macam satu structure logical structure di cloud yang kita design untuk cara data tu masuk, cara data tu allocated, network apa yang kita benarkan dan yang kita bagi keluar dan sebagainya, how it's connected. So it's like virtual private cloud. Okay. So basically, a computer network is two or more client machines that are connected together to share resources. So a network can be logically partitioned into subnets. So I said logically partitioned into subnet. So for example, this subnet 1 and then subnet 2, and then networking requires a networking device such as router here. So internet network kita perlukan router, kalau local kita perlukan switch. So to connect all the clients together and enable communication between them. So yang ni kita just review sajalah. So kita tahu untuk IPv4 kita ada 4 apa ni 8 bits. There are 8 bits. So from here 8 bits. From this number into the computer understand this one. So computer dia akan faham yang ni. Yang ni untuk kita punya human visual lah. So kita kena convert to the 1010. So basically IPv4 ada 32 bit address, IPv6 ada 128 bit address. So this one I think you already repeatedly learn about this. And how network works. Dia ada network host dan dia ada host ID. So depends on apa ni? On the apa on the subnet. So on the last number, for example, 24. So basically 24 is a host ID. So it's sorry, not host ID, network ID. For 24, 8-bit, 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 so it's a 24, so left with the host ID. So this one is around from 0 to 111, from 0 to 5, so around 256 host ID. So for the Open System Interconnection OSI model is a conceptual. Yang ni OSI saya Melayu kita tahu kan. So physical data link, network, transport, session, presentation, and applications. So and this list of protocol address. So for physical, for example, signals, data link for switch, IP for networking, router, transport for TCP, UDP, session for NetBIOS and RPC, presentation ASCII, ICA, and application HTTPS, STP, DHCP, and DAP. So that's all basic for networking. So to prepare you to enter this Amazon VPC. So many of the concepts of on premises network apply to cloud-based network, but much of the complexity of setting up a network has been abstracted without sacrificing control, security, and usability. So in this section, we will learn about Amazon VPC and the fundamental components of a VPC. So Amazon Virtual Private Cloud. Amazon atau dipanggil Amazon VPC is a service that lets you provision a logically isolated section of the AWS cloud called a virtual private cloud or VPC, where you can launch your AWS resources. So kita boleh launch AWS resources kat mana saja, tapi kita nak buat satu macam virtual area yang kita control apa yang masuk, control cara dia subnet dan sebagainya lah. So Amazon VPC gives you control over your virtual networking resources, including the selection of your own IP address range, declaration of subnets, and configuration of route tables and network gateway. So you can use both IPv4 and IPv6 in your VPC for secure access to resource and applications. And then you can also customize the network configuration for your VPC. For example, you can create a public subnet for your web servers that can access the public internet. You can place your backend systems such as database or application servers in a private subnet with no public internet access. And finally, you can use multiple layers of security, including security groups, network access control list, network ACL, to help control access to Amazon Elastic Compute Cloud, Amazon EC2 instance in each subnet. So this is Amazon VPC enables you to provision virtual private clouds. So a VPC is a virtual network that is logically isolated from other virtual networks in the AWS cloud. So a VPC is dedicated to your account. So VPC belong to a single AWS region and can span multiple availability zone. So VPC ni kita letak dalam region lah. So dalam kan satu dunia kan ada AWS kan ada macam ada dia terbagi pada region pecah lagi kepada availability zones. So VPC ni dia kena letak duduk dalam satu region, kena pilih region, tapi dia boleh cross over multiple availability zones. Macam contohnya yang ni contohnya yang ni ialah VPC. dalam satu region. And this VPC dia dia punya area dia boleh cross antara AZ1 dengan AZ2. So dia dalam ni pula, dalam AZ1 dia letak subnet 1, and dalam AZ2 dia letak subnet 2, yang another subnet. So dia ada function lah, contohnya macam kadang-kadang dia nak buat macam yang ni certain group, and ni certain group dia nak buat certain ikut dia punya projek lah. So after you create a VPC, you can divide it into one or more subnets. So kita boleh buat multiple subnets. A subnet is a range of IP address in a VPC. Subnet belongs to a single availability zone. So subnet pula dia tak boleh cross. Dia kalau boleh dia kena duduk dalam satu AZ je lah. So kalau kita nak letak AZ ni, kita letak multiple subnet boleh, tapi dia tak boleh cross multiple AZ. So you can create subnets in different availability zone for high availability. Subnets are generally classified as public or private. So public subnets have direct access to the internet, but private subnets do not. So kita belajar tentang public and private kan. So untuk private selalunya kita manage internally. Macam kita kata 192.160, itu semua private IP address. Public ni yang unik satu dunia. Maksudnya bila kita kata public IP address, benda tu macam contohnya 10 dot contoh 1.1.1 mungkin is public IP address. So satu dunia dia seorang je ada that public address. So maksudnya apa? Maksudnya satu kita boleh connected from network lah. From network or remote, kita boleh bila kita letak kita letak public IP address, kita boleh access. Kita boleh access instance kita lah. Contohnya macam kita letak public IP address kat ni, so kita daripada luar kita boleh access directly ke sini. Kalau kita letak private, hanya local yang boleh access. Sebab daripada luar dia tak boleh cari that public that private IP address. Okay. So IP address enable resources in your VPC to communicate with each other and with resources over the internet. So when you create a VPC, you assign an IPv4 CIDR block, a range of private IPv4 addresses to it. So after you create a VPC, you cannot change the address range. So it is important that you choose it carefully. So the IPv4 CIDR block might be as large as /16, which is 2 to the power of 16, 2 to the power of 6. Okay, /16 to /28. Around 65,000 address to 16 address, /28 around 16 addresses. So you can optionally associate an IPv4 CIDR block with your VPC and subnets, and assign IPv6 address from that block to the resources in your VPC. And IPv6 CIDR blocks have a different block size limit. So the CIDR block of subnet can be the same as CIDR block for VPC. In this case, the VPC and the subnet are the same size, a single subnet in the VPC. But the CIDR blocks of subnets cannot overlap. Okay. Bila contohnya kita dalam local area network, kita tak boleh buat dua subnet yang sama. So kita kena buat contohnya apa? 192.168.10.1 subnet /24 kan. Satu lagi kita buat slash dot 2/24 juga. So kita tak boleh buat subnet yang sama. Kalau tidak dia clash. Clash. IP address dia sama. So dia akan clash kan. So when you create a subnet, it requires its own CIDR block. For each CIDR block that is specify AWS reserve 5 IP address with that block, and this address are not available for use. So AWS reserve this IP address. First is for network address, second for VPC local router, third for domain name system, and fourth for future use, and fifth for network broadcast address. For example, dalam VPC ni, kita buat VPC Virtual Private Network ni. Dalam ni kita buat 4 group subnet. Contohnya dalam kes ni 10.0.0.0/24. So patutnya dia ada 250 total apa? From 0 to 256. So 5 dia reserve. So tinggal 251 yang kita boleh guna untuk kita attach pada instance yang ada dalam group kita ni. Okay. So yang ni AWS punya ni lah rules. So when you create a VPC, every instance in that VPC gets a private IP address automatically. Private IP address automatically. So you can also request a public IP address to be assigned when you create the instance by modifying the subnet auto assign public IP address properties. So basically kalau kita by default kita letak by default setiap instance kita akan dalam VPC tu akan dapat private IP address lah, dia akan automatically dapat. Cuma untuk kalau kita nak remote ataupun kita nak connected to internet, so basically kita kena letak public IP public address lah, private public IP address. So and satu lagi, an elastic IP address is static and public IPv4 address that is designed for dynamic cloud computing. So dalam AWS ni dia dia panggil elastic IP address. Yang ni yang standardnya public IPv4 address. So this one manually assigned through an elastic IP address and automatically assigned through the auto assign public IP address setting at the subnet level. So bila kita set subnet level tu, kita boleh tweak dia punya tu, kita letak public IPv4 address lah. So for elastic IP address tu, dia associated with an AWS account, can be allocated and removed anytime, and additional cost might apply. So kita boleh letak public IPv4 address dekat dekat instance. Kalau kita dekat subnet ni, kita boleh letak public IPv4, tapi bila contohnya bila bila satu instance ataupun server tu contohnya dia kita dah tak mau, kita dah tutup, kita dah shut down. So that public IPv4 tu akan back to the pool. Maksudnya kita tak boleh nak guna balik that public IP address. So bila orang lain yang dah biasa guna that public IP address, so dia kena tukar pada public IP address yang baru lah. Tapi kalau kita guna elastic IP address, benda tu akan attach, memang akan associated with our AWS account. So kalau ada server tu kita dah shut down, kita boleh guna balik that IP address untuk instance yang lain. So kita tak hilang lah that public IP address. Tapi dia additional cost might apply. So an elastic network interface pula is a virtual network interface. So yang ni dia punya macam logo lah. It's a virtual network interface that you can attach or detach from an instance in a VPC. So a network interface attributes follow it when it reattached to another instance. So when you move a network interface from one instance to another, network traffic is redirected to the new instance. So kalau contohnya kita guna the elastic network interface ni, kita dah set everything kat dalam ni. So bila kita dah tak guna that this instance, contohnya sini macam web server apa, kita dah shut down, kita nak maksudnya contohnya daripada internet, kita dah letak public IP address kat sini semua. So daripada internet semua masuk melalui this network interface. So bila kita nak we have a new instance, kita attach attach yang ni, kita letak pada new instance. So semua traffic akan follow this elastic network interface lah. So each instance in your VPC has a default network interface. The primary network interface that is assigned to a private IPv4 address from the IPv4 address range of your VPC. So you cannot detach a primary network interface from an instance. You can create and attach additional network interface to any instance in your VPC. So the number of network interface you can attach varies by instance type. So setiap instance ni dia ada, kalau ikut ni dia ada default network interface. So untuk case yang untuk detach ni kita kena tambah additional lah. So depends on types of instance. Ada instance yang ada slot banyak lah untuk elastic network interface. Okay. Dia buat macam PC betul-betul lah. Kalau ada slot kosong, baru boleh attach elastic network interface ni. So yang ni route table standard. A route table contains a set of call route that direct network traffic from your subnet. So basically untuk route table dia ada destination, dia ada target kan. So dia akan tunjuk lah. Okay, contohnya kalau destination ni dalam subnet ni, dia akan masuk ke local lah. Dia akan masuk ke local. Kalau 0000, contohnya nak keluar ke network, kita kan 000, dia akan pergi ke gateway. Dia akan hantar data tu ke gateway, current destination dia. Okay. VPC networking. So for this section 3, now that you have learned about the basic components of VPC, you can start routing traffic in interesting ways. In this section, you learn about different networking options. So for example, this kita ada dalam Amazon Web Service ni, dia ada satu service yang juga dipanggil Internet Gateway. So this Internet Gateway, so yang ni ialah VPC. Kan, ni VPC, yang ni region. This one availability zones. So dalam availability zone ni dia create two subnet, satu public subnet public subnet, maksudnya boleh access from remote lah. Satu dia panggil private, so orang yang dalam ni je orang luar tak boleh access ke private lah. Dia tak ada ni lah. So orang yang dalam group ni saja yang boleh communicate. So and then they communicate this route table, communicate dengan internet gateway. So internet gateway. So this internet gateway is a scalable, redundant, and highly available VPC component that allows communication between instances in your VPC and the internet. And internet gateway serves two purposes: to provide a target in your VPC route tables for internet routable traffic, and then to perform network address translation for instance that were assigned public IPv4 address. So to make a subnet public, you attach an internet gateway to your VPC and add route to the route table to send non-local traffic through the internet gateway to the internet 0000. So kita tengok ni dia attach internet gateway pada route table public ni, and then dalam route table ni dia letak 0000 untuk ke internet. Selain pada ni kita belajarkan network punya ni kan. Selain pada ni, semua akan dihantar ke internet gateway. So selain pada local ni dia akan hantar ke internet gateway, dan daripada internet gateway dia akan tukar NAT ke internet. So another one is a network address translation NAT gateway here enables instance in a private subnet to connect to the internet or other AWS services, but prevent the internet from initiating a connection with those instances. So to create NAT gateway, so contohnya dalam private subnet ni, dia nak access internet, so dia akan pergi ke private route table, dia akan pergi ke NAT gateway, dia akan pergi ke public route, and then dia pergi ke internet gateway. So dia ada access untuk internet, tapi orang luar remote tak ada access untuk this private subnet. So to create a NAT gateway, you must specify the public subnet in which the NAT gateway should reside. And then you must also specify an elastic IP address to associate with the NAT gateway when you create it. After you create a NAT gateway, you must update the route table that is associated with one or more of your private subnet to point internet-bound traffic to the NAT gateway. Those instances in your private subnets can communicate with the internet. So instance yang dalam private subnet, kita kena letak NAT gateway kat sini. So bila dia keluar ke NAT gateway, dia akan ditranslate, dia akan keluar ke internet gateway. So private subnet dia ada access pada internet lah. So you can also use a NAT instance in a public subnet in your VPC instead of NAT gateway. However, a NAT gateway is a managed NAT service that provides a better availability, higher bandwidth, and less administrative. So macam dia kata, kita boleh guna satu server, satu instance untuk tukar jadi NAT gateway, tapi dia dah buat siap-siap this service, so kita tak perlu configure setting yang teruk lah. So this service kita apply je. Terus kita kebanyakan, so Amazon ni dia tengok orang tu, kebanyakan orang nak buat apa, so dia akan provide service lah. Okay. So untuk VPC sharing enables customers to share subnet with other AWS accounts in the same organization in AWS organization. So VPC sharing enables multiple AWS accounts to create their application resources such as EC2, RDS into shared centrally managed VPC. Okay, contohnya dalam ni dia buat this is a VPC. Kita owner VPC ni attach pada satu account. So dalam account tu dia ada macam-macam resources. So contohnya dalam private subnet dia ada account B, ada EC2 instance, dua EC2 instance. So dalam case ni, dalam ni pun ada account C, participant ada EC2 dengan RDS database. Dan dia ada satu subnet, public subnet yang ada NAT gateway, ada EC2 instance, ada Amazon Redshift, also a database service. So from here kita tengok they connected these two subnet through router, and then they connected to gateway. Okay. So VPC sharing offer several benefits. Separation of duties, centrally control VPC structure, routing, ownership, security groups, efficiency, no hard limits, and optimized cost. Okay, kalau kita contohnya kita ada ni, kita nak buat macam mana nak design dia panggil macam ni lah. Okay, dalam case ni private subnet ni, dia kerja dia dalam ni lah, dalam subnet dia. So public ni boleh access pada luar, orang luar boleh access, internet pun boleh access. So another service is called VPC peering connection. It's a networking connection between two VPCs that enables you to route traffic between them privately. Instances in either VPC can communicate with each other as if they are within the same network. Contohnya kita ada dua VPC, VPC A, kita dah buat kerja kat sini, kita buat certain project and so on. And then kita buat another VPC, Virtual Private Cloud, kita buat another project. And then kita nak communicate antara dua ni, then kita just guna this service, kita panggil VPC peering. And bila kita attach this VPC peering, so any instance dekat VPC B and VPC A can communicate. So cuma route table tu kita kena make sure kalau dia nak pergi ke this subnet, so dia kena pergi ke this gateway lah. Okay, VPC peering. So by default, instance that you launch into VPC cannot communicate with a remote network. To connect your VPC to your remote network, that is create virtual private network or VPN connection. You create a new virtual gateway. Create new virtual gateway device called a virtual private network, VPN, and attach it to your VPC. So yang ni VPC kita, dia ada virtual gateway, and then kita nak connect kepada contohnya on-premise kita lah, contohnya corporate data center. So kita kena create site-to-site VPN connection. And then customer gateway ni contohnya router yang dengan kita punya data center kita ataupun kita duduk sini. So basically ada VPN direct tunnel to our router dekat data center. And then kita kena define lah, contohnya macam all dia yang pergi ke network ke internet akan pergi ke virtual internet gateway here. Untuk private subnet dulu 192.168.10.24. Okay, untuk private subnet route table dia letak the destination destination from destination is corporate data center lah, 192.168.10.0/24. So dia kena lalu virtual gateway ID. Okay. So dia boleh guna VPN. Another service yang dia orang offer is one of the challenges of network communication is the network performance. Performance can be negatively affected if your data center is located far away from your AWS region. So for such situation, AWS offer AWS Direct Connect. So macam tadi juga, dia patutnya macam VPN juga, tapi this performance might be low. Tapi kalau kita guna service AWS Direct Connect from virtual gateway, they connect to AWS Direct Connect and kita connect ke customer gateway of our data center. So this private connection can reduce your network costs and increase bandwidth throughput and provide a more consistent network experience than internet-based connection. So direct connect use open standard 802.1q virtual local area network VLANs. And then this is another service called VPC endpoint. Is a virtual device that enables you to privately connect your VPC to support AWS services and VPC endpoint service that are powered by AWS Private Link. So connection to this service does not require an internet gateway, NAT device, or VPN connection or AWS Direct Connect. Instance in your VPC do not require public IP address to communicate with resources in the service. Traffic between your VPC and the other service does not leave the Amazon network. So contohnya kita ada VPC and kita ada Amazon S3 yang kita letak luar pada S3. So apa yang kita perlu buat ialah kita letak this service VPC endpoint. VPC endpoint. So dia tak perlu NAT NAT gateway and so on. Dia sendiri. So from public subnet, dia akan go to elastic network interface, and they go for VPC endpoint and to Amazon S3. Maksudnya dia kata ni, kenapa dia tak perlu NAT address, dia tak keluar pada apa ni, kalau kita imagine dia tak keluar pada group, ada pada Amazon punya cloud. Kalau yang tadi gateway tadi, dia boleh keluar pada Amazon punya cloud. Tu yang dia perlukan NAT, translate NAT untuk NAT gateway untuk tukar IP address dan sebagainya. Tapi dalam kes ni, dia VPC endpoint ni, dia macam dia duduk dalam satu cloud, dia tak keluar. So basically dia hanya perlukan VPC endpoint lah. So there are two types of endpoints. So interface endpoint, powered by AWS Private Link, or gateway. Panggil gateway endpoints untuk Amazon S3 and Amazon DynamoDB. Okay, semua ni kita ingat kita punya subjek ni is berkaitan dengan infrastructure. So infrastructure kita dah belajar pasal infrastructure, how cloud working, masa ada compute service dan sebagainya. So infrastructure and service yang di-offer dalam kes ni, kita start dengan Amazon AWS. Lepas ni insyaAllah kita pergi ke Google Cloud pula kan. So tengok dia punya service, infrastructure and service dia pula. So for this case, contohnya dia kata, kalau katakan kita ada banyak VPC, and kita conventionally kita akan connect melalui VPN connection, VPC peering and so on. So kalau yang ada banyak macam ni, dia kata mungkin boleh sesuai untuk guna another service yang dia panggil AWS Transit Gateway. AWS Direct Connect. To solve this problem, you can use AWS Transit Gateway to simplify your networking model. So with AWS Transit Gateway, you only need to create and manage a single connection from central gateway into each VPC, on-premise data center or remote office across your network. So untuk data center, kita akan connect VPC connection lah to data center. And then for yang dalam cloud, semua connected, Amazon VPC semua connected to Amazon Transit Gateway. Okay. Either kita VPN connection ataupun Amazon Direct Connect Gateway. Dan ini lebih laju lah, yang ini lebih biasalah, normal. Okay, contohnya ni dah VPC ni kita buat dalam region. Ni kotak region dia, and then setiap subnet tu dia boleh cross multiple availability zone, but dalam case ni dia letak satu availability zone. So yang ni ialah VPC dia. And then dalam satu VPC dia ada satu public subnet and satu private subnet. Okay. And then untuk connect kepada internet, untuk instance yang instance yang dalam private subnet untuk connected to network, so kita kena ada NAT gateway. So NAT gateway, so from private IP address, dia akan connect pada route table, dia pergi NAT gateway, and dia akan pergi ke internet gateway. So semua yang related dengan 10 dia akan masuk local. Semua yang nak pergi selain pada tu, dia akan pergi ke internet gateway. Internet gateway here. Okay, I think dah sampai 15 minutes. Ada lagi 30 20 30 slide. So let's continue tomorrow. Okay. For section 1 and section 3, and tomorrow we continue others. Okay. Thank you guys for patiently learning about this cloud technology. So, anyone have any questions related to our slide today? Okay, if not, let's continue tomorrow. Thank you, guys. So, have a
Sir.
good rest.
Thank you, sir.
Thank you.